Okay, we're going to talk about rectangular coordinates and graphs. This is the Cartesian plane. It's a two-dimensional plane, also known as the XY plane. We have an x-axis, y-axis. X-axis is the same thing as saying y equals 0. Y-axis is the same thing as saying x equals 0. Where the axes cross, that's called the origin. That occurs if the ordered pair is 0, 0. An ordered pair is a horizontal component and a y component. So the x is the independent variable and y depends on x, making it the dependent variable. An ordered pair is written parentheses, x value, comma, y value, parentheses. The quadrants go from the first quadrant in the upper right, so x and y are positive. Second quadrant in the upper left, so x is negative, y is positive. The third quadrant in the lower left, which both are negative. The fourth quadrant in the lower right, which x is positive and y is negative. I've got three ordered pairs here, x1, y1, x2, y2. And in the middle, we have the midpoint. So we're going to talk about how to find the distance between these 2 points and also how to calculate that midpoint. Here's the distance formula. This is going to look a lot like the Pythagorean theorem if you've seen that, because we could draw a right triangle here between x1, y1 and x2, y2. You'd end up with a right angle, and then that hypotenuse, which if we were specifically talking about right triangles, we would say is c. So from a squared plus b squared equals c squared. We have the horizontal length, the vertical length, and then we'll get the hypotenuse. So just in case this looks confusing to you, it should be pretty familiar from the Pythagorean theorem. And then here's the midpoint formula. The midpoint formula between x1, y1 and x2, y2 is simply the average of the two values. So x1 plus x2 divided by 2, y1 plus y2 divided by 2 would give you your x midpoint and your y midpoint. Okay, so we're going to find the distance and midpoint between negative 3, 1 and 4, 8. You can choose whichever one you want to be x1, y1. It doesn't matter, just as long as you don't get them mixed up in the formula. I went ahead and I just chose x1 to equal negative 3, which then fixes y1 to be 1, x2 to equal 4, which then fixes y2 to be 8. Make sure you carefully substitute that into the distance formula. There's x2, there's x1, there's y2, there's y1, and 4 minus negative 3 is 7. We're going to square that. 8 minus 1 is also 7. We're going to square that. So underneath the radical, we have 49 plus 49, which is the square root of 98. And we're going to get a little bit of review on how to simplify that radical. When simplifying a square root, you examine the number to see if it has any factors that are perfect squares. If it has a factor that is a perfect square, we can simplify that. If it does not have a factor that's a perfect square, you'll leave it as is. So 98 has a factor of 49. 49 is a perfect square. So on this step, I'm rewriting 98 as 49 times 2. And this is to show you guys where all this is coming from. Generally, students on a test would probably go from square root of 98 to 7 square roots of 2, may not do these in-between steps. So we can break up this radical as the square root of 49 times the square root of 2. Simplify the square root of 49, that's 7, and the square root of 2 is itself. Don't type that into a calculator and approximate it. That is an exact value. In math, we would strive for exact values every time over an approximation. So if 7 square roots of 2 is the answer, leave it as 7 square roots of 2. Do not put it in the calculator. Unless, of course, you're prompted for certain instructions or applications, but if it doesn't say otherwise, always want to give the exact value if at all possible. So here's the midpoint. Xm is the average of the x's, ym is the average of the y's. Negative 3 plus 4 divided by 2 is 1/2 on the x's. and 1 plus 8 divided by 2 is 9 halves. The book writes capital M equals, and then the ordered pair. So then we're going to plot ordered pairs of relations, and we can formulate some graphs just by plotting those ordered pairs. So for the linear relation y equals 6x plus 1, we're going to find 3 ordered pairs and graph that line. Lines are a really good spot to start when learning relationships between independent and dependent variables. The rate of change does not change between any 2 points on a line, so to graph a line, you simply need to find 2 points and then connect those dots after you've plotted those points. So we're going to find some ordered pairs, and to find an ordered pair, I want you guys to think of it as that you choose a value for the independent variable, which is x, substitute that value in, and solve for the dependent value, which is y. So think of it as y depends on x. Specifically for a linear function, you can choose y and get x and vice versa, but the mentality of understanding y depends on x, y is the dependent variable, x is the independent variable. Understanding that from the start will help us hit the ground running when we specifically talk about functions in upcoming section and then for the rest of the semester. So if we look back at the original, all real numbers are available to us to choose for x, since there are no values for x that cause division by 0 or negatives under square root, so we can literally pull any real number for an x value and substitute that into the equation. So first I'm going to choose x equals 0, and choosing x equals 0 will allow us to find the y-intercept. So that's where the graph is going to cross the y-axis. So in plugging in 0 for x, y equals 6 times 0 plus 1, and this is a 1. So y equals 1, as an ordered pair, that's 0, comma 1. So we're going to, when we graph this, put a dot on the y-axis at 1. So now I just chose x equals 2, y depends on x, so if I choose 2 for x, plug that into the relation, and y equals 6 times 2 plus 1, which is 13, so the ordered pair would be 2, comma 13. Now on the graph, you don't have to make a bunch of grid marks, you don't have to be a perfect artist. We do need to label. We need to label x-axis, y-axis. We need to label the ordered pairs. So here's 0, 1. I've got it labeled, that's the y-intercept. Here's 2, 13. And then it says to find a third ordered pair. To find, we're going to just go ahead and show how to find the x-intercept. The x-intercept means that the value for y has to be 0. So that's where the graph is going to cross the x-axis. So if I replace 0 for y and then solve for x, I get negative 1 over 6. So the ordered pair is negative 1, 6, comma 0, and that is the x-intercept. You can plot points for any relation or any function because the graph of any relation or any function is the plot of all of its ordered pairs. So if we were actually graphing this line, how it would be theoretically, we'd be making a bunch of dots, kind of like a tattoo needle or something. But we'd have to do that infinitely many times, and we'd never actually be able to graph a line. So when we draw it, of course, we just draw a line. But this would work for any relation. You just pick any x value that is allowed in the domain, so meaning doesn't cause division by 0 or negative under square root, find its dependent value, and so put those on the graph and sketch the graph. You can always rely on that to give you an idea of what a graph looks like, and here later on in the chapter, we're going to talk about a bunch of different types of functions. If you happen to forget what the generic shape of the function, you can always just plot points and start sketching those, and then get the idea of what that relationship looks like.